All right, 3.5, graph linear inequalities. So this is where I tell you, you should probably start trying to find some colored pencils for this. Why? Well, one, I've taught this. This is my second year teaching it now, but I know where it goes because I've kind of been involved in that for a long time. So Ed, later on down the road, we're going to be graphing multiple inequalities on the same coordinate plane. So like today, a pencil is fine. Maybe like a couple days from now, you might want to have 2 or 3 colored pencils. And when you choose your colored pencils, choose them wisely. Don't choose like, say like navy blue, dark purple, because those aren't going to work out well. And you'll see once they start to do this, why. You're going to want to pick like colors like maybe like a yellow and a blue and like a pink. Why? Because the answer for these are going to be where they overlap. Okay? So if you're using a pencil, you're going to have to find a way so I can tell the difference between maybe 2 or 3 different shaded areas. Okay? So you'll see me do it up here, and I'll try to teach you ways to do it. Like I'll talk about like waffling and what does that mean? Like how is that your answer? And then I'll show you like, hey, you could also draw an arrow to it. But I want you to be aware, colored pencils are going to be the easiest way to kind of show me your answer in this section. All right, so with linear inequalities, basically in algebra, you guys learned about like inequalities in like one dimension, right? Just on like the number line, you had an open closed circle. Then I totally like ruined everything and had you guys do like brackets and parentheses. You're like, this is stupid. Why would we ever learn it the first way if you're just going to change it? And then you also talked about graphing inequalities on a coordinate plane a little bit. You shaded above the line, below the line. Okay, you also had no more open or closed circles, right? What did that change to? Do you guys remember? What did open and closed circles change to in a coordinate plane? That's what it did. All right, on that. But what about in a coordinate plane up here? An open circle, what? Kind of became a dotted line, right? And a closed circle became like a solid line, right? So now you're going to have to worry about that. So when you're graphing, okay, be conscious. Is your line supposed to be dotted or solid? It makes a difference. Okay? So let's just talk about what our answers are going to look like. The graph of a linear inequality is going to be the collection of all points. Okay? So it's going to be a shaded region. Okay, it's either going to be above the line or below the line. I'm going to be talking about that a lot. And it's going to be difficult to understand, like, is that above or below? Because it changes, right? If my line's like sloping down, this side's going to be above. But if I'm sloping up, this side's going to be above. So that stuff is going to be things that you're going to have to pay attention to. The one thing I'll strive to tell you is focus on the y-intercept. If you focus on that, you can figure out above and below real quick. So up here, it says, sketch the graph of each linear inequality. And it says, x is greater than or equal to -3. So basically, they already did this to me. They already did the problem. But here's how you do it. All right, I know. Well, that's not really lined up. So that means a solid line, right? It has the line under it. Now, I'm going to go to where x is -3. It's right there. It's going to be a solid line. We know x equals a number is a vertical line. So I'm going to draw a vertical solid line right there. Now here it says x is greater than -3. So I'm going to look at -3. Where are my numbers greater than -3? To the right or to the left? To the right. So I'm going to shade over there. And that's why that's blue. Okay? here, this symbol means dotted. Y equals a number, okay, is going to be a horizontal line. So we go to where Y is 4, which is right, let's see, where's my Y? Right here. And then I'm going to make a dotted line through that. Now it says Y is less than 4. So where are my numbers less than 4? Above or below? Below. So that's why I shaded below. So that's my answer. And for this one, I'm going to need to align my board. Yep. I don't.
I actually know it's not myself.
All right. So now how do I do this problem? It says x plus y is greater than 3. Well, I have to graph that line. And there's a couple different ways to graph it. One, we can take this line and make it equal to y equals mx plus b by subtracting x. That gives me y is greater than negative x plus 3. So I start at 3. Then my slope is negative 1 over 1. So I go down 1 to the right one, down 1 to the right one, down 1 to the right one. And there's a reason why I put all of these dots on here, because it makes it easy to dot it. You see how I just connect the two dots? Makes it easy to dot it. Makes it easy to plot and connect. So I go from there. Now, here, this is where it's tough. Is it above or below here? That's really difficult, right? I don't know.
It's above.
Okay? Here, it's easy to see that it's above. Hansi, we're going to talk about why this is a little bit more difficult to see the above and below. Okay? But here, we're all in agreement. Y is greater than, right? So we shade above. Now, that's one way to graph this one. Another way to graph this one, Jake, is as follows. Well, what if I'm looking at, oh, fantastic. What if I want to graph this by intercepts? Did you guys have Mr. Beatty at all? You guys didn't have Mr. Beatty? Mr. Beatty came up with this really cool way to do intercepts when things are in standard form. It's called the cover-up method. Okay? And what he does is this. If I'm trying to find the x-intercepts, I cover up y. See how it says x is 3 right there? So you come down to where x is 3 on my y-axis, then put a point. Cover up for the y-intercept. Cover up the x. See how you get y equals 3? Put a point there. Now, it's a dotted line that connects those 2 points. You only need 2 points to make a line. Now, here, this is difficult to determine whether it's above or below. So the way I do it is I take a test point. The test point is 0, 0. Why is 0, 0? It's easy to plug in 0, 0, right? Now, there are times you can't choose 0, 0. Say if my line went through the origin, I couldn't pick that point. So you try to want to pick a point that's off the origin in that case, maybe like 1, 0, 0, 1. So now what I do is I'm going to take that and I'm going to plug it in. Is 0 plus 0 greater than 3? Is 0 greater than 3? Is that true or false? Okay? False. So that means this point doesn't work. That point was right here, right? Since it didn't work, I shade on the other side of the line. Do you see how to do that? two ways to do it. One way, you put your answer or your equation in y equals mx plus b, and then you can look at your y-intercept and determine whether you're shading above or below. The second way to do it is you pick a test point and you plug in the test point and go from there. If the test point works, you shade on that side of the line. If it doesn't work, you shade on the other side of the line. My test point I always pick is something with 0, like 0, 0, 0, 1, 1, 0, something like that.
I'm going to increase how the test point part works.
Well, it's, remember, any point in your shaded area has to work. So if I pick a point in my shaded area, such as 0, 0, and it doesn't work, then that can't be part of my answer. So I have to shade on the other side. Because it's any point. Okay. You could. Now, I would use the cover-up method in this form, because it's standard form, it's easy, right? Would I use the cover-up form or method if it was in y equals mx plus b? No. Okay? So, we know how to graph lines. So let's look at this one. We all have this one, right? All right, let's look at this problem. So when I'm graphing it, I'm actually graphing like the line 2x plus y equals 2, right? That's what I'm actually trying to graph here. Now, Hannah could be good at kind of getting this y by itself. So Hannah might just do minus 2x, and Hannah's going to get that pretty quick, right? So Hannah would come up here to 2. She plots her point. Then notices her slope is negative 2 over 1. So she's going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Again, this seems excessive, but it does help in connecting your dots. Okay? And then she's going to notice that this sign says that it is a solid line. So she connects it. And now notice here, all right, that's what I'm kind of viewing in my head. Okay, if from the start I kept that symbol of this, oops. If from the start I kept this, I could see I'm shading below, right? But we didn't do that, Jake. So you asked about the test point. Does everybody see the point 0, 0, right? Does everybody see how 0, 0 is below the line? Maybe you see that? I know it's boring, but that's the way math is sometimes. Just boring. So what I'm going to do, Jake, is I take my equation, which was that, right? I'm going to take this point, I'm going to plug it in. I'm going to simplify. Is that true or false? And is 0 less than or equal to 2?
Yes.
Yeah. So guess what? Because that's true, I shade below the line.
Check it
I mean, that is one way to do it.
It's a 50-50 shot.
It is a 50-50 shot. It is, Hannah, it is a lot of work to do the test point all the time, but I don't do the test point all the time.
That all what we're doing? Yeah.
No, we're doing more. All right, so you guys are wondering, like, kind of how to make it quicker, right? Hannah, you remember solving inequalities? Okay, you remember when you divide by a negative, you flip your sign, right? Okay, so up here, you're just like, doing that test point just takes too much time. This is how I can do it. Okay? Ready? Let's get y by itself, right? So how do we get y by itself? Justin, what are we doing here?
Subtract x.
All right, so everybody subtract x. So I have negative 2y is greater than or equal to negative x plus 6. Now let's go with,
Nikki.
yeah, Nikki.
Well, I don't really know. I'm a little bit confused.
Okay, so let's look at this. Nikki, we're trying to get y by itself.
Divide by negative 2.
How do I get y by itself?
Divide by negative 2.
Okay. Now, Hannah said when you divide by a negative, you have to flip your sign.
Yeah.
Okay? So I'm going to go ahead. So negative 2 divided by negative 2, they cancel. So I have y, flip my sign. Negative x over negative 2 is 1/2 x. 6 divided by negative 2 is negative 3. Nikki, are you with me here?
Yeah.
Anna, you with me? Okay. Now, I'm going to go ahead and I'm going to graph this. So I go to negative 3, plot my point. Then I go up 1 to the right 2. Is everybody okay with that? Now, how many points make a line? 2. So I can connect them. But the question becomes, how do I connect them? With a solid line or dotted line? Leah, solid or dotted? Solid. So we connect it with a solid line. But here's the thing. Where are your notes?
I'm using this.
Where are your notes?
You're at home somewhere.
All right.
Took me.
All right. So here's the thing is I don't have a ruler, right? Do you guys have rulers?
No.
No, but you have the side of your calculator, right? So you could use the side of your calculator. But here we go. All right. So you're going to connect these two dots, okay, with a straight line. Pretty good. So you just call it back.
Yeah. You have to end on a good one.
All right, so I connected my two dots using a solid line. Now, kind of ready? Am I eating the y? No, so y is less than, right? Where are the points less than negative 3? This way or that way? Down. That's the problem. You okay with that, Hansi?
Yep.
All right. Let's look at this one. This one's got a lot going on, right? So remember, the name of the game is to get y by itself, to graph, right? There's two ways I graph. Cover-up method or y equals mx to the speed. I look at it and I determine which way I want to do it. For the most part, I want to get at y by itself. Okay? Wouldn't you agree it's going to be pretty easy to get y by itself? All right, so I had to get y by itself. Yeah, I just combine like terms by subtracting the 5x. 3x minus 5x is negative 2x. Minus 2 is less than or equal to y. Now, you might not like that, right? You might not like the way this is rearranged. Watch. I'm eating the y, agreed? I could rewrite this to y is greater than or equal to, notice still eating the y, negative 2x minus 2. Same thing. So I'm going to come up here, I'm going to go to negative 2. I'm going to plot my point, then it says go down 2 to the right 1, down 2 to the right 1. Okay? Now I need to connect them with a solid line because there's a line under it. Okay, so here we go. Not bad, not bad. You're not even doing it.
I already finished the problem.
You shade above too.
Okay, and I'm shading above because I'm eating the y. How do I know which way is above? Well, there's -2, right? Numbers that are greater than -2 are going to be up here. And a 1.
Phenomenal.
Do.
You done?
Okay, what's the difference between a straight line and a dotted line?
The dotted line is used just for.
So as Justin said, the solid line includes the line. Dotted does not include the line.
Oh, so like it's like
It's
greater
like
than
open.
greater than what or less than, and then straight line is greater than or equal to or less than.
Yes. All right. Now, I think these are, yeah, probably the last couple I'll do today. Now I need to write the inequality. So how do I write an inequality? Well, what I need to do is I need to write the equation of a line. Agreed? Hansi, what's my y-intercept in this?
It's 2.
2. All right, so I'm trying to fill in something like y equals mx plus b. Oops, not 2, b. So Hanji told me b was 2. Now what's my slope, Justin?
1.
How do I go from here to here? Is it 1? 1, 2, 3, 4. 1, 2, 3, 4. It is 1. So I have 1x plus 2, right? But now I got to figure out what goes in here, in between that. Well, first off, is the line solid or dotted? Dotted. Am I shading above or below the line? So y must be less than. See how it's kind of like fill in the blank? For this one, same thing. Ready, Cody? Watch. We're trying to fill in the blanks here. All right, we know b is 0. We know my slope is 1, 2, the right 1, 2 over 1x, right? Am I shading above or below? Above, and the line is solid. So we're done. Might clean it up a little bit. Might write y is greater than or equal to 2x. But tomato, tomato. Last but not least, this guy. Ed, let's bring this on home here, okay? Ed, what type of line is that? Not 0 slope.
A vertical line.
Undefined slope, which is a vertical line, right? The equation of a vertical line, Ed, is what? I'll give you 50-50, right? Is it y equals a number or x equals a number? X equals a number. So here, what does x equal, Ed? Now, did I shade above the line or below the line? And that's where it's a little difficult, right? So Ed, think about it this way. Numbers that are above 1 are which direction? Up, right? But like think about it as like the line is going like this, right? So up doesn't really help me. To the right. Did we shade to the right? We shaded to the left, right? So I'd be less than. See how we're focusing on this point and we shade it this way? So it's going to be x is less than or equal to 1. Are you guys okay with that? You sure? Positive? Jake?
Mhm.
All right. Let's see. Let me see. Yeah, we might as well finish it up. Sorry. Might as well finish it up. There's only. What? Yeah, it's 2 more questions. You're killing me. All right, your budget requires you to earn at least $160 per week. You work 2 part-time jobs. One is tutoring, which pays $10 an hour. I would quit that job if somebody paid me $10 an hour to tutor. And the other is a fast food restaurant, which pays $8 an hour. I would also quit that and find something better, like working at Chick-fil-A. Let X represent the number of hours tutoring and let Y represent the number of hours worked at the fast food restaurant. Write an inequality that represents the number of hours you can work at each job in order to meet your budget. So, pretty simple. It says X represents the number of hours tutoring. So tutoring, you get paid $10. So A would be 10X plus, well, Y represents the number of hours worked at the fast food. So that's 8Y. And we need to make at least, so that means greater than or equal to 160. Now it says graph it. So Jay, remember I said like I would pick a method that works better for me? I would graph this using the cover-up method. All right, Mr. Beatty's cover-up method. So what I would do is I would say 10X plus 8Y, okay, I would think equals 160. And I would cover up the Y, and I would get 10X equals 160. And this is for my X-intercept. So 10X equals 160. And I'd get X equals 16. Got it? And then I would do the Y-intercept. And I would cover up the X, and I would get 8Y equals 160. And I'd get Y equals 20. Now here's the thing. I try to be nice and give you guys a coordinate plane, but those numbers don't really fit on the coordinate plane, right? That's probably why you're confused. Here's a nice little trick. Count by 2's. Negative 10, negative 20. Isn't that nice? So instead of counting by 1's, let's just count by 2's. So I come over here, I plot 16, 12, 14, 16. Go to here, plot my 20, right there. Look at this. It says it's a solid line, so I'm going to connect those two with a solid line. Like it started out looking like a really good line.
Yeah. Should have ended it.
Wow. Even better than the first one.
Yeah.
So now I have to figure out where do I need to be. Okay? So let's take the test point of 0, 0. And let's plug that in. So I'm going to do 10 times 0 plus 8 times 0. Is that going to be greater than or equal to 160? No. So I would shade over here above. Well, I use the test points when it's not in y equals mx plus b. And at the words of Cody, I think I need to end it.